Hello, my name's Ryan Struhl. I'm a software engineer here in Boston at Robin, where we're working to kind of optimize the open office and make it a little bit less terrible for everybody, which is a lot of fun. You can find me online on Twitter, though I'm not very frequently on there. This is my cat for Josh, if he's still in the audience. So today I'm going to be talking to you about color. Color is something that's been fascinating to me for a very long time. The fact that we can see anything is, to me, like ridiculous. So a long time ago, I built this crazy app that can like do polygon optimization based off of color differentials. But as much as I'd love to talk to you about like doing cool things with color, I'm actually going to be talking to you about the dark side. Yeah, you thought you were done with the puns. So this was back in 2014, and I was working for a marketing company. And we got this great style guide. I saw this button. But one thing that the style guide did not include whatsoever was what color to make it when the hover state. I think this is pretty common, but it was 2014. We were using Sass. I was super excited about it. I did something a little bit like this. Use my handy lighten function. And that was kind of the end of it, right? Except this is marketing, so of course, like 6 months later, I have to come back to this code base. And I come back to this, the file that I started, and it looks a little bit like this. I had told people to rebel against the system, and they did. Why? I had become some sort of color-based supervillain. What was going on? This is a real supervillain. I didn't know when I started this talk, but it works really nicely. So this was bad for like a ton of reasons. Number one, it was super hard to stay consistent or on brand. It was easy to run into accessibility issues. The only way to extend it is to make things worse. So if you ever needed more colors, we just had to keep doing this. And it's a slippery slope to just more and more and more technical debt. But with many supervillainous individuals, I pushed this to the back of my brain to make room for more important things. But like this all really changed for me pretty recently with the release of macOS Mojave. So this introduced dark mode to computers, and I was super excited about this. I use a dark editor. I like dark websites. Like there's all this stuff. I was super pumped for this. Until I started thinking about this color problem. So now we're just going to take this and just like double it. Because now we have to have our representations for our dark mode. So this is sort of where I try to redeem myself and create a better system for this. I mean, really, how hard could it possibly be? So we can characterize like a good solution to this problem with a few things. Number one, it needs to be intuitive for developers and designers, so we know what all our color language means. We want accessibility and consistency to be built into this application. It should work across both light and dark modes, and it should be easy to build and extend. So, you know, whenever we do need new colors in the future, it should be relatively easy to add them. So let's address these kind of one at a time. Intuitive. So how do we make an intuitive color system? Well, Google actually showed us the way a little bit in 2014 when they came out with the material color system. So they're using human language to describe the colors with very understandable terms, at least in English, like pink, orange, green, and indigo. So these are colors that we normally understand, we have a good idea of. And then they're using numbered stops so that we have an intuition for how light or dark these colors are in relation to its most saturated form. So that when I see some code that looks a little bit like this, I actually have a pretty good understanding of what this is telling me. Color blue 50, that means it's very light. Color blue 500, that might mean it's a little bit darker, more saturated. So that kind of takes care of a lot of the intuition around it. It's really easy for us to kind of use that language in our applications. Now, to make it accessible, the WCAG Web Content Accessibility Guidelines tell us that the visual presentation of text has to have a contrast ratio of at least 4.5 to 1. Now, when I saw this, no idea what that meant. So I looked it up. It's this. still have no idea what it meant, and this should have been my first indication that this was going to be a lot deeper than I thought. But naively, I continued. The basic understanding is you can use some tools like contrastratio.com or like Contrast Checker. There's a bunch of them out there. And 4.5 to 1 is good. 7 to 1 is really good. Those are the AA and AAA content guidelines, respectively. If you're using really big text, they're a little bit different, but these are good guidelines to stand by. So that seems simple enough, right? Light and dark modes. Well, we need to like actually start getting into it, right? We need to actually build something to see how this works. So I asked a design friend to give me a color palette, and this is what they gave me. And this is 5 colors, which is pretty disparate from the 10,000 that I had been working with previously. And I was really psyched for this. I was like, okay, got sass, got lighten, got darken. That's super cool. Yeah, not so great, right? The orange looks kind of okay, but the blue is terrible. It's really bad. I bet this is just, that blue is pretty dark, whatever. Like, I bet if we use saturated colors that are pretty standard, it'll be way, way better. Okay, what? God. So here's where we have to kind of take a huge detour onto representing color. So as a developer, I generally think about color in terms of knobs that I can dial in, of red, green, and blue. And if I get in the right esoteric combination, it'll give me the correct output in a hex code. This is awesome if you are a robot who has to turn on and off light bulbs. This is less great for humans. So like for humans, just to begin with, we don't really see in absolute terms of red, green, and blue. This is totally mind-boggling. There's a lot here to delve into that unfortunately I don't have time for, but this gets even crazier when you start talking about things like color blindness, where one of the cones is either underperforming or potentially you don't have one of your color receptors at all. And so this hex value that I had so diligently put together before turns into something completely different. And I apologize to anybody with protanopia in the audience for whom that transition was not happening. And this is way more common than a lot of people expect, right? So anomalous and dichromatic vision in the male population is around 8.5%. 8.5% of men have anomalous vision. It's sex carried, so men, it's substantially more prevalent than in women. That's just something that happens. But that's not too far from the population of men who are left-handed. So if you know any lefties, there's a pretty good chance you know somebody who has at least some sort of color vision anomaly. And this is really just the tip of the iceberg in terms of understanding color vision. It's an incredibly, incredibly deep field with a lot of nuances. And at this point, I was like, I have made a huge mistake. Why am I giving this talk? So I put this project to try to solve this problem kind of by the wayside with my other, dead and dying projects. I really like this comic. This was shared at work the other day. But basically, I started a new position at Robin, and we were building out this design system, which seems to be what a lot of folks are doing these days. And when I was delving into this, I was like, no, I can't go back to this world. We need to be using something better. I don't want to deal with this the insanity of color. Given this is a tiny fraction of what a design system is for, but it's one of those things that when you do actually get it right, it makes a huge impact on the development of your application. So, all right, how can we approach this? We know color vision is crazy. What can we do to actually approach this? Well, we knew from Google, let's use some human language. So to start off with, we know that all these colors exist, but when we use this language, what are we actually talking about? What we're describing here is the hue. And what I mean by that is we understand that any given hue can become lighter or darker, and it still remains the same. Like, we could describe any one of these colors as red. We might say some are pink or very close to white, but they're generally considered red. And then we can sort of, it's a little bit fuzzier, but we can sort of understand the idea that like they can get more or less saturated. So our color response to it is more or less strong as compared to gray. And when we do this, we get, and we kind of shift everything around a little bit, we get the HSL color space. So this is all that we're describing in CSS when we're using HSL. We have an axis from white to black, and then out from that is all of our hues at various saturations. And if you actually diagram it out, it looks like two ice cream cones stacked on top of each other. This is super cool, and it works pretty well, but it does run into one pretty difficult problem, which is that they have drastically different perceived lightnesses. So we see yellow as being a much lighter color than we see blue. So when you put them next to each other, even though our HSL system says that they're exactly the same lightness, they're drastically different colors, and our perception of them is pretty drastically different. So what we actually want is this same HSL color system, but we want it to be adjusted such that each one of these hues represents about the actual perceived lightness. And this was, as much as I would love to have gotten into the crazy linear algebra that makes this possible, that is way outside of my knowledge. But a bunch of very smart people did this in the 1970s. And this is what's called the LCH-UV color system. You don't need to know too much about it, except that it's basically representing hues as different degrees from the central point, and that everything is adjusted for human perception. So if we take a slice out of that, it looks a little bit something like this. So you can see that a fully saturated yellow in this view is much lighter than a fully saturated blue. And one cool thing we get out of this is that each one of these horizontal lines represents a different luminosity. So every color that's along that band has an equal perceived lightness. And that's a really powerful idea, that everything on that band we are going to see as equally bright. And this actually also explains that issue that we were having with the green earlier. If you look at a very saturated green, green is actually a pretty light color. And we are much more sensitive to differences in luminosity than to chroma, is the other axis. So when we do RGB interpolation, like lighten and darken, we have to bleed off a lot of chroma before we can actually get to any change in actual luminosity. So we get colors that are very close to each other around that highly saturated point. And that's really bad as a developer, because that lighten function, I have to like choose a sort of a random value to actually like get the luminosity to change correctly. I don't know if any of you have like fought this before, but I've definitely been down the road where it's like 12.5% maybe. Like, so using this approach, using this color space, we can start to create a ramp for color. So how would we approach that? Well, we actually have a pretty good intuition for this. So when we see things that are in shadow, we have an understanding that this wall in its entirety is orange. Now, this could be some crazy art project where somebody perfectly drew a shadow onto the wall. Mad props to them if they did. But more likely, we see this as being a shadow onto one constant color. So we understand intuitively that under different lighting conditions, something will have a very different kind of color that we perceive. So there's got to be a relationship here, right? Because our intuition for it must stem from somewhere. It turns out that this is based on lines of uniform saturation. So all of these are what are called natural shading lines. So when something is in shadow, meaning that the light source is the same, but you're just getting less of it, you'll tend to fall along these axes. And this makes intuitive sense, because you're saying like, this is the proportion of how colorful we perceive it to be to how light we perceive it to be. and those are going to be fairly constant across as long as the only thing changing is the light source. So our ideal system is going to kind of use that. We're going to stick as much as possible to these lines of uniform saturation, but we want to generate colors for each stop. So if this is our base color, getting the darker colors is really easy. We can just follow that line of uniform saturation and we get a nice set of darker colors. And then to get the lighter ones, we have to kind of make this imaginary line up to the white point. And then we can interpolate colors along that line. And when we do this, we get a nice color gradation from dark colors to light colors that is very consistent to our understanding of the natural shading. And this works really well, including on colors that we normally would really struggle with. Because we're using the perceived luminosity of colors, it makes it really easy for us to generate these really nice color schemes. So putting it all together, well, we had to use it needed to be intuitive. So to solve that problem, we are going to use natural language to describe the actual hue values. And then we're going to create a gradient for each one of those so that from the very light colors to very dark colors. And that's what's going to allow us to use it very intuitively. For accessibility, it's actually kind of neat. So when we project out these ramps, we can see that every color that is stop 50 or lower in the system is going to have above that 4.5 threshold with black text. And everything 60 and above will be above that threshold with white text. And really only those 50 and 60 stops are below the 7 threshold. So that's awesome. Like this makes accessibility very simple. But I haven't actually cherry-picked this color. This is true across the board. So every color we generate using this system is going to have that property of it. And this was actually shocking to me when I first saw it. I was like, wait, what's going on here? Have I done something horribly wrong? Am I miscalculating this? And that stayed with me for a long time until I actually saw it in black and white. So this is what it looks like when you take all of the color data away, which tells us a few things. Number one, don't rely on hue alone to give users feedback about what action they're taking. That can end really, really badly for folks who are achromatic. They cannot see color at all. They will not necessarily be able to differentiate. But this is also really good because we know that for every one of our hue values, we have a nice range of accessible colors, which is fantastic. So works for both light and dark modes. I would contend that we're not actually there yet. If we look at gold here, gold 80 is not looking awesome. Like, it's sort of gross. Like, depending on what monitor you're looking at, you might get different variations on it, and that's a whole other talk. But once you get to these dark colors, there's just no such thing as a nicely saturated yellow in a dark value. So here's where I actually have to introduce a whole other color space. This is HSLUV, and I really encourage folks who are into color to check this out, hsluv.org. Basically, what this color space does is it takes that LCH UV system and it projects it out so that we're no longer having to calibrate for colors that might not exist entirely, or technically there's just no source that is able to produce that color. So this projects it out. It makes it much, much, much easier to develop for. And one cool thing we can do with this, if you imagine folding out these hues like pages in a book, we can create schemes that cross these boundaries, maintaining those properties of having that nice curve in luminosity and following those lines of uniform saturation. But we can do this not only across luminosity and saturation, but also hue. And what we get when we do these color shifts is we can generate really nice dark colors for ranges that don't have it, or really nice light colors for ranges that don't have those. This is a little bit extreme just for demonstration purposes. I wouldn't necessarily recommend pushing it this far. But now our darker colors are this beautiful golden brown, and I think that that is a much more aesthetic view of this. And so we can shift all of our colors over a little bit. I shifted the orange to be a little bit more red. I shifted the blue to be a little bit more true blue. And from here, it's actually really easy to do light and dark modes. So in light mode, we just take all these different varieties of our blue spectrum, and I can label them. This is awesome for designers. They can say, oh, this is blue 60 or blue 40. These aren't just random variations. These aren't lighten it 40%. These are absolute and discrete values. And then we can basically just flip everything over and we get dark mode. These are not, it requires a little bit more finesse, and then there's lots of usability concerns that cross that boundary. But at the same time, you still get that advantage of being able to describe your entire application in terms of having your hue value along with a color stop associated with it. So this makes it pretty straightforward to work for both light and dark modes, which is awesome. So easy to build and extend. So far, we've basically not talked about the tech aspect of this at all. But here's where I tried to do a quick demo. I built this tool out, ColorLab. You can access it at colorlab.dev. It's not super mobile friendly. I put it together pretty quickly. And I don't necessarily know if I can pull it up on screen. Gonna try. I'm on a different screen. All right, well, fortunately, I have some hidden slides. So I am going to take these and unskip slide. All right. So within ColorLab, within the ColorLab, it will generate these schemes for you. It'll give you information about the contrast values with white and black. And then you can play with this more or less to your heart's content, creating a bunch of different stops depending on how many you need. You can change the hue very easily. And then if you want, it also allows you to shift the hue so that if you want to use these colors, you're able to do so. And then finally, it's exportable. So all of this gets converted into a JSON object. You can copy it to the clipboard very easily. And that's about it. I've also added exports for CSS and Swift and Android. So those are all accessible, I think today. So easy to build and extend. Awesome, we did it. Thank you, that's what I was asking for. So this is really cool. It was built on the shoulders of giants. Colorbox.io by Lift Design was a huge influence on this project. 0 to 255 is another tool that has some similar functionality. The material design colors do some other stuff. All of them are really good. Choose the tool that meets your needs. So far, haven't talked about code, which is funny at a React Conf. So gotta delve into this at least a little bit. Prefers color scheme dark. So just recently, and in fact just Thursday with iOS 13, a media query is available in a ton of browsers for prefers color scheme, light, dark, or no preference. And with this, we can do some really cool things if you don't have to worry about backwards compatibility. So using CSS variables, we're able to define all of our stops as accessible variables on the root. And then using just media queries, we're able to completely recreate our application with different color modes. Super cool, not super well supported. So it's just starting to come into its own. I think it may have shifted a little bit. I think Chrome for Android now ships with it. iOS 13 will probably see pretty high adoption rates. Historically, Apple's pretty good about these things. But still, it's not supported in all browsers. IE doesn't even support CSS variables. And it's difficult for the user to change it well. And what I mean by that is sometimes I have my phone, it's in light mode, whatever. I'm browsing at night. I don't want it. I don't want my site in light mode. Like it would be really cool if I was able to just toggle it. So in JavaScript, we can start here by detecting the OS dark mode. But I also encourage folks to include some sort of user configuration object, whether that's in local storage or potentially part of a user settings object, depending on what you're building. And then deciding if you should use dark mode just based off of whatever the user's preference is, because not only is dark mode like cool for people who who are browsing the web at night, lots of people, it's an accessibility concern. Different colors, different contrast ratios just work better for some people. So giving a user the ability to toggle between this, I think, is very important. Within the React context, we've been starting to do this at Robin, where we're creating contexts which are going to be providing the colors to any subcomponent. Then, as well as whether or not to use a dark mode potentially. Then within those, we can use the useContext hook to link into that and pull discrete colors off of it, making this really, really easy for us to adopt both within our component libraries, but also within our other applications. You can just start using the context. Finally, if you're using something like styled component theming or emotion theming, it's really easy to start injecting these directly into your theme contexts, and then then giving these semantic names. So if you have primary and secondary colors, you can provide the entire ramp or individual colors, depending on how you want to approach it, and use those across your application very intuitively. So really the moral of this talk is be kind to future you. Often we're going to make decisions that incur technical debt, and that's just part of development. That's something that we're all going to do all the time. I guarantee I'm going to make a decision in the next week or so that I'll regret in 6 months. But as much as possible, where we can, we should put in the effort to try to make things that are going to be sustainable and adaptable to the future. So thank you all so much. That's it.